Welcome to the world of microscopy. This program will give you an overview of a precision microscope, its components, and its operation, including the use of an oil immersion objective. And we will offer suggestions for the care and maintenance of your microscope. But remember, this program is a companion tool to be used in conjunction with your instruction manual. A high-quality microscope, such as the Olympus CH2, is precise yet rugged. It yields excellent images for a broad range of applications in the schoolroom, the laboratory, or in professional practice. With proper maintenance, the CH2 will serve you for many years. And with optional accessories, it can be adapted for dual viewing, dark field, polarized light, and phase contrast microscopy, plus photomicrography in 35mm or Polaroid format. Before describing its components, let's review what a microscope does. The quality of the objective lens is a key determinant in the production of excellent images. The objective lens is focused on the specimen, and it projects an image of the specimen upward into the binocular tube head. This magnified, inverted image is floating in space about 10 millimeters below the top of the eyepiece tubes. The eyepieces look at this image and magnify it a second time. The resulting visual magnification is the product of the magnification of the objective times the magnification of the eyepiece. For example, a 40 times objective and a 10 times eyepiece will yield a total visual magnification of 400 times. The final visual image appears as if it were about 10 inches from your eyes. Since few specimens give off their own light, the microscope should include built-in illumination. The first function of the microscope is to provide a magnified image sufficiently spread out on your retina so that it can be seen, and it should clearly separate the details of the specimen. This is called resolution. Finally, the image must be presented with sufficient contrast so as to make it visible. With this brief introduction, let's examine the components of the Olympus CH2. The binocular tube head has two viewing tubes. A 10 times high eye point wide field eyepiece is inserted in each tube. The binocular tube head has ribbed edges to permit horizontal movement to adjust for your interpupillary distance, the distance between the pupils of your eyes. The left viewing tube has a diopter adjustment ring to correct for differences in focusing between your eyes. The built-in revolving nosepiece has openings for 4 objectives. The 4 times, 10 times, and 40 times are called dry objectives, to be used only with air between the objective and the specimen. The 100 times is an oil immersion objective requiring oil contact between the front of the objective and the top of the specimen or cover glass. The 4 times and the 10 times are used for scanning larger areas. The 40 times and 100 times are intended for high power observation and are spring-loaded for protection against accidental pressure contact with the specimen. The ED achromat objectives are designed to yield crisp, well-corrected, color-saturated images at their respective magnifications. They are parfocal so that little refocusing is needed when you change magnification. Each objective is engraved with its magnifying power and an instantly recognizable color code ring. For instance, blue for the 40 times. Also engraved is the numerical aperture, a measure of the resolving and light-gathering capability of the objective, and the tube length, 160 millimeters, the distance from the opening on the nose piece to the top of the eyepiece tube. The marking 0.17 refers to the thickness, in millimeters, of the cover glass for optimum performance. The specimen stage has a clear opening. Coaxial stage control knobs move the specimen slide left or right, and forward or back. Although shown for right-handed users, there's an option if you are left-handed. A curved metal finger holds the slide in place. Since the revolving nosepiece does not move vertically, the specimen is focused by means of the left or right-hand coaxial stage focusing knobs. The larger knobs are for coarser movements, and the smaller knobs are for finer vertical movement. There is a tension adjustment wheel behind the right-hand knob and a stage lock clamp behind the left-hand knob. This clamp prevents upward movement of the stage by the coarse knob, but does not affect the fine focus movement. It is used to prevent crashes into the slide when using high-power magnification. Beneath the stage is the substage condenser assembly. It can be moved vertically by the left side condenser knob. Its purpose is to concentrate light on the specimen. A built-in variable iris diaphragm controls the angle of the light coming up through the condenser. Using this diaphragm affects contrast, resolution, and depth of field. A detachable filter holder, accepting 32.5 millimeter diameter filters, can be clicked into the underside of the condenser. Other condensers, such as dark field condensers, can be substituted. Also, a field iris diaphragm and accompanying centering attachment lens are available as an option. The UL-approved stand includes the arm and base. The base contains the field lens to concentrate the light. Under the base is a hinged door, providing access to the housing for the 30-watt bulb for the CHT or the 20-watt high-intensity halogen bulb for the CHS. On the base is a socket for the detachable 3-prong power cord, the on-off switch, and a graduated rotatable wheel which controls the intensity of the lamp. Let's review the components. A binocular tube head with eyepieces. The revolving nose piece with objectives. The vertically movable stage with coarse and fine focusing controls. The horizontal XY specimen slide motion knobs. The vertically movable substage condenser with aperture iris diaphragm. The base with on-off switch, intensity wheel, power cord, and lamp. Now, we'll discuss in sequence the procedures for operation. Loosen the attachment screw above the nose piece. Fit the binocular tube head into the opening and lightly clamp it in place. Rotate the tube head so that the viewing tubes face toward you and tighten the clamping screw. Insert a 10 times eyepiece in each tube. After lowering the stage assembly and tilting the microscope gently on its back, attach the mechanical stage to the right side. Use a coin to tighten the mechanical stage attachment screws to the openings under the stage. Pull down the knob on the door under the base. Using a thin piece of plastic wrap to protect it from fingerprints, push the 30-watt tungsten bulb for the CHT into the socket. Twist it in place and release. For the CHS, push the pins of the halogen bulb into the pinhole openings on the socket. Return the microscope to its upright position and rotate the intensity wheel to a middle position. Screw the 4 times, 10 times, 40 times, and 100 times objectives, in that order, into the openings of the nose piece. Hold each objective with 2 hands so that it doesn't drop while being attached. Always rotate the nose piece by holding the knurled edge ring and not the objective itself. Push the condenser firmly into the substage condenser ring and tighten the clamping screw. Using the condenser knob, raise the condenser to a position 1 or 2 millimeters below the top of its travel. Pull back the spring-loaded stage finger and place the microscope slide in position with the cover glass facing up. Release the finger slowly to avoid splintering the corner of the specimen slide. Attach the power cord to the microscope and to the power outlet. Turn on the light switch and move the slide so that light is coming through the stained portion of the specimen. Using the nosepiece ring, rotate the nosepiece to position the 10 times objective into the light path. While looking through the eyepieces, use the coarse adjustment knobs to raise the stage slowly until the specimen is in focus. Then use the fine focusing knobs to sharpen the focus. Grasp the ribbed sides of the binocular tube head and slowly move the viewing tubes closer together or farther apart. This will fuse the images from the left and right eyes into a single image. Memorize your interpupillary distance indicated on the tube head scale. Using only your right eye and the right viewing tube, focus the image sharply once more. Then, without touching the focusing knobs and using only your left eye and the left viewing tube, slowly rotate the diopter adjustment ring until the image is sharp. This corrects for any difference in focus between your two eyes. Lift out one of the eyepieces and look down the eyepiece tube at the back lens of the objective. With your right hand on the substage condenser lever, open and close the diaphragm while you observe the back of the objective. When the lever is wide open, the back lens is filled with light. When it is closed, there's only a small spot of light visible. The best position for resolution and contrast occurs when the back lens is open 3/4 of the way. Replace the eyepiece when you've finished. This adjustment must be repeated every time you change magnifications. Let's summarize the operating steps. Assemble and attach the components. Raise the condenser to 1 or 2 millimeters from its topmost position. Plug in the power cord. Adjust the light intensity wheel to mid-position and turn on the power switch. Place the slide on the stage and hold it in place with the stage finger. Rotate the 10 times objective into the light path. Focus the specimen with the coarse and fine focus knobs. Adjust the binocular tube head for interpupillary distance and the diopter adjustment for your left eye. Lift out an eyepiece and set the condenser iris to a 3/4 open position. Replace the eyepiece. When changing magnifications, also readjust the condenser iris diaphragm. Now let's look at the oil immersion objective. Since the oil immersion objective looks at only a very small area of the specimen, you must first center and focus the area to be observed using the 10 times and then the 40 times objective. Next, rotate the 4 times objective into the light path so that you have sufficient space between the objective and the specimen. Place a small drop of the provided Olympus immersion oil onto the lighted area of the slide's cover glass. Without turning the focusing knobs, rotate the nose piece just one position to bring the 100 times oil immersion objective into position and into contact with the oil. When using the oil immersion objective, only rotate the nose piece from the 4 times to the 100 times objective. Never rotate it the other way, since you may get oil on the 40 times dry objective. With the 100 times lens now in position and dipped into the oil, use only the fine adjustment knob to bring the specimen into focus. Lift out an eyepiece and adjust the condenser iris to the desired 3/4 open position. Replace the eyepiece and adjust the light intensity wheel as needed. When you have finished viewing with the oil objective, lower the stage and rotate the nose piece so that the 100 times objective faces toward you. Use a piece of lens paper to blot the excess oil. Take a fresh piece of paper, moistened, not drenched, with a few drops of methanol. Clean the remaining oil from the front of the objective using a gentle circular motion. You may have to repeat this process with another moistened piece. Finally, dry the lens with a dry piece of lens paper. Clean the slide in a similar manner before storage. Let's summarize the use of the oil immersion objective. Locate the area to be examined by using the 10 times objective. Then use the 40 times objective to find, center, and focus the area to be observed. Rotate the 4 times objective into the light path. Place a drop of oil onto the cover glass covering the specimen. Rotate the nose piece directly from the 4 times objective to bring the 100 times objective into the oil and light path. Use only the fine adjustment knob to bring the specimen into focus. Adjust the condenser diaphragm to 3/4 open position and adjust the light intensity. When finished, clean the oil objective and then the slide. Now, let's review some procedures that will ensure a long life for your microscope. Never use solvents to clean the base, tube head, or stand. Instead, use a dampened cloth to remove dust on metal parts and dry with a lint-free cloth. For glass components, it is generally sufficient to use a clean camel's hair brush or a dry child's type ear syringe to blow off dust. Then more stubborn spots can be removed by using a piece of lens paper moistened with a few drops of methanol. Use circular, gentle motions when cleaning glass surfaces. The most stubborn spots may require lens paper moistened with xylene. But remember that too much xylene may affect lens cements. Always dry the glass with a fresh, dry piece of lens paper. Smoking near the microscope may coat the optics with a dark film. To replace the bulb, turn off the power switch and detach the power cord. It is very important that you let the bulb cool before you touch it. If a fuse burns out, detach the power cord. Just above the socket, there is a small chamber housing the fuse and a spare. The chamber cap can easily be pried open with a small screwdriver or nail file. Replace the burned-out fuse with the spare and push the plastic chamber cap back in position before reconnecting the power cord. The microscope bulb life will be greatly extended if you run it at less than maximum intensity by keeping the intensity wheel near mid-position. Before turning off the microscope, lower the intensity setting below the midpoint on the scale. Whenever the microscope is not in use, it should be kept under the plastic cover or in the carrying case to prevent dust from accumulating on movable parts or glass components. In transporting the microscope, hold it with one hand grasping the arm and the other supporting the base. Never lift it by holding the stage, tube head, or objectives. Let's summarize the proper care and maintenance of your microscope. Use a blower or camel's hair brush to dust glass parts. Clean oil off the immersion objective each day. Never touch any glass parts with your bare fingers. Remove stubborn spots on glass by using methanol or xylene-dampened lens paper. To change a bulb, detach the power cord and let the bulb cool down before making the replacement. Also, remember to detach the power cord when changing a fuse. Cover the microscope when not in use. Carry it with two hands, one supporting the base and the other holding the arm. Superior quality, ease of operation, proper care. All of these will ensure your satisfaction for years to come. If you have any questions, the Olympus technical staff is available by calling 1-800-446-5967 during East Coast business hours. Enjoy your microscope.